Hi, my name is Max Recker, and the project I chose to do is a renewable generation single-phase power converter. The problem I chose to address is that certain types of renewable energy generators, such as wind and hydro, produce AC power, which cannot be stored and is only immediately useful for AC loads. It is necessary to first convert the power from AC to DC, which can then be stored in batteries for later use. This will also allow it to power DC loads or be converted back to AC. This can be done by using a rectifier followed by a chopper to transform the power to DC and adjust the voltage level so that it can be used to charge a battery. Without a power converter, the power produced by an AC generator would be uncontrollable and less useful to the customer. Renewable energy devices such as wind and hydroelectric generators are often used in off-grid or hybrid power systems as a source of cheap, clean energy. The people who rely on these systems for their power are the users for this project and may be entirely reliant on this type of generation to survive, as they may be located in rural or remote areas where they don't have access to the power grid. With this in mind, this device must be affordable, reliable, and efficient, as well as weatherproof to withstand the environment that the generators will be located in. The outcome that this project aims to produce is a device that can be connected directly to the output of a generator that converts the power from AC to DC and uses that power to charge a 12-volt battery. There will be a bus that connects the output of a generator to the input of this converter, an AC to DC rectifier that will output DC power, and then a DC to DC converter that adjusts the voltage level to the appropriate voltage for the battery management system. It will also have a weatherproof case to protect the PCB from the elements. Here we can see the circuit diagram with power flowing from a single-phase AC generator through an AC to DC rectifier that includes a smoothing capacitor, and then through a DC to DC converter that adjusts the voltage level for the battery management system. The power will be stored in a 12-volt battery. The major risks for this project are feasibility, such as developing a circuit that will be able to handle the rated power from an AC generator, creating a bus that will connect the converter circuit to multiple different types of generators, designing a DC to DC converter that will allow the power to be stepped up or down to match the power ratings of the battery charger, designing a battery management system that can store the generated power, and choosing a battery that can store enough power to compensate for when the generator is not producing maximum power. Some other risks will be cost. A battery that has the capacity necessary to store the power from the AC generator will be expensive. The types of power electronics components such as diodes and transistors that have to withstand the rated power of the generator will probably be expensive, and prototype devices that might be destroyed or damaged during testing will add to the cost of this project. As for experience, I have never worked with battery management systems before, so that will be new to me, and I have never worked with control circuits that may be required to help the DC to DC converter control the voltage properly.